guys and gals, Insomnia from UnrealTech.net, a division of BlenderTek.com here again. Today we're going to make our first gun that our players can use. I've very quickly taken a paid model of a G36 and created a very blocky, quick down and dirty version that I'll release public domain, but you can use any model you wish. So open your project and remember, create your way. Just so everyone's aware, by the way, I've done some practice and research and I found the perfect way to create some realistic tanks with custom engines and wheels and treads. So we'll be doing that at some point, and I'll probably make it as part of this series. So when someone requests tanks, I've got the perfect solution ready. Anyways, on to this G36 rifle slash SMG. So all I've done in this example here is I've taken the FP gun, which was the stock gun that the first person holds, and I replaced it with this model I created, and it's almost perfect scale. I could probably extend it like 1.5 in the X, and you can see it'd be pretty damn close, but yeah, it's pretty much perfect. And with the butt stock that I got rid of that I'm gonna make as a modification, it would fit even better. With some custom arms, it would fit even better. You can see we can fit a pistol grip right on there, and it'll work perfect with the stock character. So I just switched out the skeletal mesh for that. And so I've had to rotate it 90 degrees. The grip point socket, the stock one, needs to be rotated 90 degrees. So we'll fix that on ours, because ours is at right hand, if you remember we created that. But I'm just going to compile and save this on our main character for now, just for looks. So how I created this, it's just, like I said, just a regular model that I modeled and textured really quickly. It's rigged though, and it's got a skeleton. So you've got your root bone. This is where your player is gonna hold on to it. So that's very important, and that's if you want to move the whole model, obviously. I've got the magazine weighted to this bone, and so that's if we wanted to, I can miss some parts of it during texturing, but that's if we wanted to, say, do like a reload animation. So that's rigged. I've added a bone for accessories if we wanted like some sort of accessory that we could manipulate, and also on the rail on the bottom another accessory bone. A slide if we wanted some sort of like animated hammer or slide or whatever, or we can use this as an ejection point for the cartridges, and muzzle, that's where the bullets are going to come out of, obviously. So that's just basic bones. The only ones that have any weighting are body and magazine. And then in the physics asset, I've taken the root and I've given it just a little area, and then the magazine. So that is everything I've done up to this point. So that's just a skeletal mesh that I've added into meshes, weapon, G36 rifle, and I've just called it G36C plain rig, because we'll have other versions where we might have different accessories or whatever, and all the textures that I will include when I do an updated version on the website. So how are we going to make this into a gun that we can pick up and shoot? Well, there's two ways we could go about that. Obviously, we're going to need to extend our BP weapon base class, and we can extend that, and we will extend that two ways. So we're going to right click and create child blueprint class, and we're going to have BP weapon underscore instant. So this is a weapon that you fire it, it does a line trace, and it hits something and it does damage and effects and whatever, and maybe some tracers and your muzzle flash and whatever, but it doesn't actually use ballistics, or it doesn't shoot out a projectile that we created in our projectile class. Then we're gonna have another one, create child blueprint class, which is going to be BP weapon underscore projectile based. Maybe I'll call this instant fire based and projectile based. So that'll be our two child classes. So we'll start with the instant fire based gun. So we have all of our inherited stuff that we created, and all of our inherited interface BPI pickupable things, and all of our class defaults. So we'll be setting some of that stuff up, and we'll need some logic as well. So we're gonna need a few variables. Not very many though, so I'm actually gonna go through all the variables first. So we're gonna have a variable called impact force. It's gonna be a float. It's gonna be editable, and we're gonna hit F7, and so it's going to be the force in newtons that this applies when it hits something. So something like a real gun is anywhere between around like 2,000 to 3,000 newtons usually. So I'll go like 2,800. That's a pretty decent value, I assume. And you can leave a tooltip like the force in newtons shot to center mass applies. Then we're gonna want a replicated variable called hit notify. So this is gonna be, remember our structure hit. Ooh, we didn't create that one. Okay, let's go back. So we're gonna need basically information of where a bullet hits and what it does and where it hits. So let's right click blueprints. This is all in the weapons folder still. We're gonna make a structure called s underscore hit. We'll go hit. Yeah, hit information. So we're gonna have a few different things. We're gonna have a float. We're gonna have a reticle spread, so how much the bullet reticles spread after each shot. We're gonna have an integer, which will just be rand seed, so just a random seed for how the spread and other things that we'll do that need a random seed. We're gonna have some vector variables. We'll have another float, which will be damage dealt, so the total damage dealt on a hit. So of course we're gonna modify that based on where it hits and such. And we're gonna have a couple vector variables. So one vector is gonna be the origin, so the origin, so where the hit originated from, so where it was shot from, and another vector which is going to be the hit point, so where it hit exactly in world space. So we'll save that, and so our hit notify is going to be of that structure s underscore hit information, just like so. The default values are all totally fine. And this one we want to be rep notify, because obviously when something's hit, we want to set that information and do stuff with that information. We want this to be zero filled at load. That way every single hit starts out with no information. And all the default values are fine, so we don't need to compile right now. Then we're going to need a bullet spread. So we're going to make current spread, another variable here. This will be a float, and we'll give it a default value of 0. Then we're going to do some variables for actually firing. So we're going to have a variable called raise per shot, so that's obviously line trace raise. This will be an integer. It's going to be editable. It's going to be under the category config fire, and we'll give it a default value of 1. But if you wanted to create like a shotgun, you might have like 8 or something, and we'll work that in too. Then we're going to want, let's just duplicate that. Oops, not impact force, duplicate raise per shot. We're going to want damage type. And this will obviously be of that that BP we created of the base class damage type. So BP damage, what do we call it? Base. Let's go damage here. What the heck did we call that? BP base damage type. Okay. Well, it's weird that didn't show up. BP base. It's not showing up at all. Okay, try compiling. BP base. Okay, let's try compiling that. Then compile. Let's try that again. BP base damage type. There you are. Alright, we're gonna want a class reference to that, and then we need to compile and set it to that class. Then we're gonna need one more, duplicate, and this is gonna be the hit damage, so the base damage that a hit does when fired. So this is gonna be an editable float variable, and we'll give it a default value of like maybe 10 shots to die, 5 shots to die, we'll say like 20. And then we're gonna need accuracy, so let's duplicate hit damage and let's do base spread, and let's change this to from config fire to config accuracy, so how accurate the gun is. So this is the base spread, so how much the bullets spread either under full auto, under rapid firing, or if you have multiple rays per shot. So let's hit F7 and give it a default value. Again, this will be pretty low, something between 0 and 1, so I'm gonna go like 0.125 again, kind of like our other values there. Then the higher though, the more accurate. So like 0 is like all over the place, 1 is dead straight. Let's duplicate that, and we'll have iron sights spread. So how much spread do we have when we're holding the weapon up, you know, when you hold down right click? So we'll like double it, 0.125 times 2, 0.25. So it'll be much more it'll be twice as accurate when you have the iron spreads up, or the iron sights up. So let's duplicate this again, and we're gonna create spread increase on fire. So every time you fire a bullet, how much does the spread increase? So compile, it's all the same in here, and we'll do something like 2. So the base spread gets increased by a factor of 2. And then we want how much maximum can we increase. So let's duplicate. We know the G36 isn't a super accurate rifle. It's kind of closer to like a submachine gun. This will be spread increase maximum, and this will be something like a factor of 15, since it's a fairly inaccurate weapon when you're firing extremely fast. I don't know if we're gonna go full automatic on it yet, but when and if we do, I might do it on a different weapon, and then we'll really get some interesting spread. But especially when we get to projectiles, because then you see the bullets hit and such. And lastly, we need one more in accuracy, which is, we're going to duplicate here, which is range. So that's the range of the weapon, obviously. So I'm going to compile, and so this will be in centimeters. So like 200 would be 2 meters. I'm gonna say like we want around 1 kilometer, so that's obviously 1,000 meters. So times 100, that's like 100,000. Maybe, actually maybe not a kilometer. 100 meters is, or 1,000 meters is pretty far. Even 250 meters is pretty far. Let's do 250 meters. So that'd be 250. 25,000 rather. now we need hit detection. So let's duplicate this, and this is going to be client side hit leeway allow, or client side hit allowance, we'll call it. So how much allowance are we going to give it on the client side to register a hit? So let's hit F7, and this is under config hit detection, and we'll give this a value of like 100. So basically, if it's within 1 meter client side versus server side, then we'll register the hit client side, and it won't actually take down your health, but you'll know that you got hit, even if it seemed like it missed. You'll know that you got hit because server side you did. And then we'll have allowed view dot hit direction. So that's the dot product of the hit direction, the allowed view that you can have on it in degrees, and we'll say 0. Perfect. Then we want some effects. So let's duplicate this. We'll have a tracer FX, and this is going to be a particle system reference, and we don't really have anything useful. We're gonna have to make some sort of tracer. We'll use sparks for now. Why not? And this will be under config FX. Then we're gonna have an actual impact effect. So when we actually hit something, since we're not using a projectile, we need to give some sort of effect when we create an impact, and I don't believe we created that at all. So we need to create that class as well. And before any of this, well, we can use it without going through that class, but that class will have what happens when you hit something that we've tagged as glass or flesh or wood or whatever. And as many things as you want, you can tag, and you can create different things. You can also modify the damage, different decals, different sounds, so on and so forth. So we just need to create a new blueprint class. It'll be of type actor. We'll call it BP impact effect. So we'll save that and go back to our weapon instant fire, and so it'll just be that class. So we'll go BP impact effect class, and this will be under FX. Yep. And we will compile and set it to that. Then we want another one in there. I can't duplicate that. We'll duplicate tracer FX. This will be tracer target param name. So this will be a name, which will be endpoint. So where does this tracer, where is it targeting? We'll use that, and we'll want to create one more, which will be a boolean called b spawn tracers in first person. So this is a boolean, and by default it'll be false. So we're gonna want one more. We're gonna duplicate that. This will be for debugging. This will be bprint rejected client side hits to screen. So if a hit is rejected client side but not server side, do we still show it, basically? And this will be under config debug. And by default, yes, we want to see all server side hits, even if it seems that they didn't see it, even if it was rejected client side, basically, because that's exactly what it means. So that's all our variables. We can compile and save and close all that now, and we don't have very many functions. A lot of this is handled in the classes like damage type and in the weapon base and in the character, but we will have guns, custom guns soon. So we need to create, well, let's do our on rep hit notify first of all. So what we do there is we go into a branch, and remember where we did that workaround for skipping initial replication, where all weapons fire on their last hit notify if a client joins late. This is our fix for that. So we get game time in seconds, and if it's less than 1, or not less than 1, sorry, so if we're lagging badly, basically, we've used this once before, so I'm just gonna comment workaround where all guns fire their last hit notify if a client joins late. If true, we're going to go into a branch, and we're going to check if our owning pawn, which is going to be inherited now, so we have to get owning pawn. We want to check if he is locally controlled. So what we're doing here is basically don't simulate shots on owning client, because it already did in process instant hit confirmed, which will be something that that'll be a function we're gonna make right away. This is a workaround for not being able to set skip owner for blueprint variable replication. So we're doing there, and then all we do is we need to call a, well, first let's get our hit notify and break it, because we're gonna make a function out of that, and that's gonna be simulate an instant hit. And this will be the most complicated, most likely function. So simulate instant hit. So when we call start weapon fire, when the player essentially presses the left mouse button or gamepad trigger or whatever, and we have an instant fire based weapon in hand equipped, this is essentially what's gonna figure everything out, damage, everything. So we need a vector input, which is going to be the origin of the hit, so where it was fired from. This is just the same as our structure, actually. That's why it's gonna all go into there, and that's why we instead of replicating all these, we replicate the structure instead. So we have an integer, which is rand seed. We have a float, which is a reticle spread. Another one, which is damage. And another vector, which is hit point. So, the first thing we do is we go into a sequence. I'll leave some room there for us to do stuff with that. Yeah. So the first thing we're going to do is go into a branch, and we're going to check if damage was greater than 0. If damage was equal to 0 or less than 0, I guess, then there's no reason to do any of this. So we make sure that it's greater than 0. So, and if so, then we set last hit time, set last fire time. I must have forgot that variable in our base class. Let's go back to BP weapon base. Time. Aha, I did miss that. Okay, fair enough. Fair enough. We can just hit, or we can just add that in then. So let's whoa. Come on. Let's go to our BP weapon base then, add a variable called last hit time. This will be of type float. It'll default to 0, but we want it to be 0 filled at load also. So let's compile and save that. And now we can go back and we can set last hit time to get game time in seconds. So that's the last time that we hit something. So we do that first. So check if damage is greater than 0.00 repeating, and then set last hit time. The next thing we do is we do a weapon trace, which is going to be, or we should have already created that already. So we call weapon trace. No, okay, apparently trace weapon. Apparently we did not finish that class because I don't remember creating this. Let's see. Trace. Nope. We need some more functions. Yay. So we need to create a function called weapon trace, and this does exactly what you think it would do. It does a line trace for a shot, based on quite a few things. So this will be under mechanics. And it's gonna output a hit result. This is a default network variable, so this will be hit. I'm sure you've seen a hit broken before. We also need some vectors, which will be the start location. And what else does a line trace need? An end location. And we'll also want a boolean. B is weapon fire trace. Basically, is it visible? So based on that, we're gonna want to make a new boolean called B draw weapon traces, weapon fire traces. So this will be an editable boolean. It'll be under config debug. And let's set it to F7. Let's set it to true for now, because we'll be doing some testing. So what we're gonna want to do is a line trace by channel, and we got our start and end. The channel is gonna be on. We need to create one. So let's go to edit, project settings. We're gonna go to physics. Or where did they put this nowadays? Collision, yes, trace channel. So we need a new trace channel called weapon accept. There we are. And while we're here, we're gonna also need another one called projectile for our projectile based weapons. So projectile, we'll make that one too. And let's export this just in case we need it. So I'm gonna save this. All right, so our trace channel, let's compile it here, is weapon. We do want to trace complex. Actors to ignore is our self, so owning pawn, see here, make array. And if you wanted to skip other things, you could obviously add them in there. Draw debug type is going to be based on, we're going to do a select true or false. We're going to have an index, which is going to be an and boolean. So false will be none, true will be persistent. So B is weapons fire trace is the first one, and B draw weapon fire traces is the second part of that. Alrighty, so now what we can do, we can take our hit out and we can break it, and we can also return that hit. And if you want to modify it in any way, then you just need to modify it here. But that just does a simple trace. But if your game needs modification for some reason, that's the place to do it. So let's save that. Compile and save. We can go back to our instant fire one. And so what we want to call is weapon trace. Just like so. So yeah, we're gonna show the trace points. Now we need to get the start and end location. So this is where it gets a little tricky. So we want to take our random seed and we want to make a random stream. We're going to need a helper function. So let's go to our BPM helper macros. We need to add new, and this is called a random unit vector in cone from stream. So this is basically grabbing obviously a random vector unit in a cone projection from a random stream. So we are gonna have basically it works on cone angles and it's used for spread calculations. So we're gonna need this for gun shot spreading. So we're gonna need a stream, which is gonna be a random stream. So this is gonna be our stream. We're gonna need a direction, so that's gonna be a vector. We're gonna need a horizontal half angle in radians and a vertical half angle in radians. So that'll be float. So horiz half angle rads and vert half angle rads. And then we're gonna need a vector out. So you can kind of see what this does. It takes a direction, it takes some math, and then it outputs a single direction at random. So what we do here, we take our direction, we normalize it. There's a lot of vector math that goes into making extremely realistic weapons, but it's gonna pay off in the end, I promise you. We're gonna need two random floats from stream. Floats, I type it out. Random float from stream. We're gonna need two of them. One is for X, one is for Y. So I'm gonna mark them. It's gonna be X. It's gonna be Y. We'll bring them down. Way down maybe. This will go up here. We'll take the horizontal half angle radians. We want to make sure it's greater than 0. We want to make sure both of these are greater than 0 actually. And then we want to do an and boolean. So we want to make sure both of them are not greater than 0. And that will go into our output where we're going to do a select vector, and that goes for B pick A. And we're gonna probably need a lot more room over at it. So A is just simply the normalized direction. So basically, if the horizontal half angle or vertical are 0 or less in radians, then we just take the normalized, so 1 unit, a unit normal, of the vector direction and return it. But if not, which will be like, I assume always, then we pick B, which requires a bunch of math. So the last thing we do is normalize, and then we want to rotate vector around axis. The angle degrees, we're going to do an R2D, radian 2 degrees. The axis is going to be a brake rotator into axis. The in rotation is going to be a vector to rotator. And the in vector is going to be our direction. Maybe we can bring, I don't know, bring this down here or something. I don't know. We'll do something with it. And it's also going to be the in vector. So I need to rewrote this somehow. So maybe we'll go like that. Something like that, maybe. I don't know. It's gonna get a little bit complicated. Actually, I've got this wrong. We do normalize it, but we rotate the vector around the axis, and then we rotate it around the axis again. So the return value goes into the in vector. The angle in degrees, radian 2 degrees, goes to the second one, and the x-axis goes into the axis here. The y goes into the first one. We don't worry about the z-axis. Then we normalize the results. We get a single unit vector. So what we do then, this one does get an R2D as well, radian 2 degrees. This one, however, we go and do a lot of math. So we do division, whole and remainder. And so the divisor is square roots. So this is our cone half angles in radians. Cone half angle in rads. We're gonna need a divide. I'm going backwards in math just because I have a reference sheet. We're gonna do a float plus float. We're gonna add 2 squares. So to the power of 2 square on both the upper and lower there. And then we're going to do a division on both of them. And the top one is going to take the cosine in radians. Yeah, that one. And the other one is going to take the sine in radians on the top here. So sine radians. Make sure you don't pick a sine. And these values are going to come from our input. So the bottom one here is going to come from the vertical half angle in rads, and the other one's going to come from horizontal. So I'm going to rewrote this here, or I guess I can't from there. Let's rewrote it from here and from here. So which one is which now? So I think this is vertical, so I'm gonna rewrote vert, rewrote this hors because we're gonna need to use them again. So we take our random float from stream, we take the return value of the first one, and we do a float multiplication, float times float, and we do pi times 2 times that random float to get theta. So we get pi, we multiply that by 2, and plug that into there. So this gives us theta, and then that's gonna go into both cosine and sine. Yeah, and then the other one, y, I'm gonna move this up. I should move all this over so that we can actually see what the hell we're doing. All right, so the y, we're gonna do times 2 minus 1, and then we want to get the a cosine in radians, I believe. So that gets us, and that goes into the dividend right there. Perfect. And then our angles is all we had. This one, yeah, the second one. So that just simply comes from theta. And I think that does it. That should give us a random direction within a cone, as long as my math is right. My algebra and math aren't so great, but we'll assume it's good. So what were we doing here? We were simulating an instant hit. I just forget where we were gonna use that. Oh right, make random stream, and then we're gonna do random stream. We need to compile probably. Random unit vector from in cone from stream. All right, and the direction, well, first of all, let's do the horizontal and vertical half angle radians. So what we do is we take the reticle spread, we half it, so we multiply it by 0.5. You can't divide, times 0.5 because of the way we set up the initial value. And then we do degrees to radians, D2R, and plug that into both of the radian inputs. And the direction, we need to make another fun function in our base weapon. I thought it was done, I lied. It'll probably be the most complex blueprint in this project. One of the more complex. I can think of a lot more complex that I've done before. So, oops, I created a variable. We need to create a function called getCameraAim. So in first person, obviously, we can just use get rotation or get pawn. Well, you've seen it before, the get pawn rotation. We can see exactly where they're looking through their eyes, essentially. But if we're in third person, we need to figure out where the camera's aiming at. And yeah, so we're gonna need a local variable, which is gonna be called L aim vector. So this is exactly where we're aiming at. So L aim, which will be a vector. So the first thing we do is we set that to nowhere. Then we check if owning pawn is valid. Impure 1. We also want to check if we're in third person, because that's the only time we need this. Is in third. How did we call that? Is car in third person, right? I keep forgetting I put that is car in there. We also want to get casted controller, and we also want to get base aim rotation, and then we want to get the forward vector from that. So that gets us 1 unit length forward vector from the base aim rotation, and we want to set L aim to that if it's not valid. So basically, worst case scenario, we get the forward vector and set it to that. If it is valid though, we need to go into a branch which takes are we in third person into account. And if we are, then we do a weapons trace. Good thing we created that function, I guess. So, the start location, yeah, we're gonna need a bunch of stuff. From the casted controller, let's see, where can we move? Let's move this up here. From the controller out, we're gonna get aim. We're gonna need 2 functions on our player controller or more. We're gonna need get aim vector and get viewpoint. So let's compile and save this where we're at. Let's see if we can't get those done. We'll have a couple hours more of blueprinting ahead of us yet. At least we have a weapon mesh. So in our player controller, it needs a lot of love in terms of weapons, but it can be used for other things too. So we're going to create a function called get viewpoint. So where is this player controller looking right now? It could be the pawn's eyes if in first person. It could be the third person camera location. It could be somewhere else. It depends on a bunch of things basically. So we have a local variable which is L view. That is a vector, as you might have guessed. And so again, we set that to nothing when we first call this. Then we get controlled pawn, so whoever this player controller is controlling, and we cast that to our character, cast to BP base character impure. Off of that, we check B is third person, get B in third person. We also, I believe we don't have that, get camera view, third person, camera third person. And then we're gonna split the struct pin. Yes, like that. That'll work. But we want to do a branch first, which checks if we're in third person, and if true, we do this get camera view. If false, we set L out view to base character get eye location. We're gonna need to create that function too. So let's do that. All over the place, everything's tied together. So let's go to our base character. Let's create a function. We still need to do those rep notifies too. Get eye location. So this gets the pawn's eye location, which might not always match the camera's location. For example, if we're in third person. So this one's actually pretty easy. It's gonna be in the info category. It's gonna be peer, and it's just gonna return a vector, which is the eye location. And so how we figure that out is we do get actor location, and then we do a vector plus a vector. We split the struct pin here, and we're only worried about Z, so that's obviously height. So we do a select float, and bpick is based on are we crouching, so is crouching. Yeah, and A is crouched eye height, and B is base eye height. So then we just return eye location like so. Compile. We really got a lot of stuff tying in there now. And we're gonna have even more coming. So now we can go back to our player controller. We can drag off of base character, and we can get eye location. And we can take that and set LO view to that. And then we're gonna go to our return node. I didn't create a return node. We need to return, this is also under the info category, an output vector. This is also a pure function, by the way. More important things, view location. So we can then return and what we're gonna do is we're gonna set it up here too, and we're just gonna pull it from there for the return node. Whoops, I totally forgot you can drag it right onto a return node. Desired view location goes into there. So that's if we're in third person. And we can go one more if the cast fails. So if there is no character, then we get focal location, a little known function that's available in player controllers. We set it to that instead, so the player controllers where he's looking basically, and then that returns as well. So we should have, oh, I forgot this one. So all three of these return, and it'll just pull out of there. We'll assume we always have a camera view, but if not, we set it there and then pull it from there. So we can compile and save, and we can go back. I think we were on weapon base, if I remember. So start location is gonna be right, the controller out. We need to get viewpoint, and we need to get vector. No, so I need to create that one too. So we need to get the aim vector. So we're basically just pulling the aim vector from the pawn if it's valid. Otherwise, it gets the controller's rotation. So to do that, we're gonna create a new function called get aim vector. This one is also pure, and it also outputs a vector, aim out. And so it's also under the info category as well. So what we do is, this one's again pretty short, we get controlled pawn, and we make sure it's valid impure. So we make sure we have a pawn or not that we're controlling. And we also need a local variable called out aim as the other one. So if we don't have a controlled pawn, we set this to the controller's view. So we get control rotation, and then we take that rotator and we get rotation x vector, so the forward vector. So we set that and then we return it. So we go to our return node, return, and we return that value. If it is valid, then we also set this, but we set it just a little bit differently. What we do then is we take our controlled pawn. Let's go up here. We get base aim rotation and then get forward vector. So we get 1 unit forward. So we get the pawn's base aim rotation. That's the one I was talking about earlier. And return that. So there, like so. Compile. It's pure, yep. It's in its category. Compile, save. Go back to our base weapon. I'm going to save everything while we're at it. So then we also get aim vector. So what we're going to do is this is the start location. And then we do view location plus vector plus vector. And this goes to the end location. And we take the aim vector, we multiply it by a float, your standard like 100,000 or 10,000, whatever people usually do. Well, that's just your standard line trace, like so. And we're gonna use this again. If false, we're gonna set L aim to wherever aim out is. So if the character is not in third person, then we just set it to the player controller's aim vector. And then we can return. Did I not create a return here? No, I didn't. It's also pure. It's also under mechanics. So I'm just gonna choose that, mechanics, because I'll probably spell that wrong. And it has an output vector, since it's pure, called aim out. So we can return on the false one there, and we return our local variable. After we do our weapon trace, if we are in third person though, then we set L aim, and we're gonna split this hit struck pin. So I'm gonna bring this way up here. We're gonna do a select vector on it. As you can tell, I'm getting sick of blueprinting too. I'm kind of not caring about my organization. Maybe it's just today. B pick A is B blocking hit, or hit blocking hit. Was there a blocking hit or not? Well, you're gonna take the hit location and we're gonna do minus vector. Vector minus vector. And that's gonna go into A. And B is gonna be this addition here, minus vector minus vector. I don't think we have this one yet. Get muzzle, no, we're gonna need that as well. So remember, we created that muzzle bone, we're gonna need to get that location. We're gonna need to use it there, and then this plugs into B. So we're gonna need to create that function really quickly. So let's create a function called get muzzle location. And this is a pure function. This one's very easy. It's mechanics. And we output a vector, muzzle lock location. All we do is we get socket location. Turn off context sensitive, get socket location of a skeletal mesh. No, of a scene component. Get socket location component. Nope. of a transformation, I guess is what. And so the socket name will be get muzzle flash socket, and the target will be get relevant weapon mesh, because it could be first person or third person mesh. So we just return that, compile, and we can close that, and we can now put that in here, get muzzle location, and put it down there. And then we return, I think anyways, yeah, so we have false, we have that one. We should have 3 going into here. Where am I missing? Oh, up here. The not valid also returns. So yeah, something like that. I totally don't care about organization today. So let's compile. So we have get camera aim now. So I believe we were using that on weapon trace, or no, we were using it on base weapon instant fire. So the direction is get camera aim. Then we're going to multiply this vector by range, so vector by float, and that float is get range. So you can see how this works. We get a random unit if we need a random direction. That's based on radical spread, multiplied by our range. So that basically gives us a trace out in that direction. Yes. So we're gonna need a lot more room here. Let's take all this all the way over. So we take that, and then we do vector plus vector. This one plugs into the bottom, and into the top comes the origin, like so. And then we might as well just go the end location. We do a select vector, and that is A, and B pick A is, we got a lot more math to do. B pick A is gonna be a vector is equal to vector, so we check vector equal vector, and we check if it's equal to 0, 0, 0 within that tolerance, and what we're going to check is the hit point. If it's equal to 0, 0, 0, basically if there is no hit point. If there is though, then we have B, which is, I'm going in reverse here again, a vector plus vector. We do the hit point. So I might as well start at the beginning, I guess, but the hit point does go up into there. So I'm going to do that, and I'm going to also reroute it because we're going to need it. So we do that, and we do vector minus vector. That goes into the top, and we subtract the origin, I believe, from the hit point. And then we normalize, make sure we don't have any negatives, and then we multiply by a float by about 20 and plug it into there. So what we're doing here is if we have a hit point, so not 0, 0, 0, extend it by 20 units to be sure that the trace hits the hit object. So that just ensures that we hit whatever we end up hitting. This is if no hit point is given. This is most likely a missed shot, so generate an endpoint so the trace can complete. So that's obviously by our range. That's our endpoint. And yeah, so that's our select vector. And our start location is simply our origin. So we can just go up into there. So we do all of that, and we have quite a bit more to do. Yeah, I don't know if I'm feeling finishing this out today. We go into a branch after that and check if it's if our hit was a blocking hit. If it is, then we need to spawn impact effects, which I don't think we have. Nope. So, and tracer, no, we don't have any of that done. So I'm gonna wait on the effects till next time. So yeah, we're getting pretty long again here. But we will have guns. We just need all the mechanics. We got everything except for the gun mechanics, which is the important stuff, I guess. But we're getting there. We will have the most realistic and reliable and editable and modifiable guns possible. So, thanks for watching. If you learned something, please like the video. Subscribe as well. We take donations at paypal.me/BlenderTek. If you dislike this video, please tell us why. So we'll see you next time. Remember, create your way.